Why are HVAC system regulations so complex for mechanical engineers? Have you ever wondered why the rules around heating, ventilation, and air conditioning systems can seem so complicated for mechanical engineers? Let's break it down in a straightforward way. First, mechanical engineers face a maze of regulations that differ based on location, building type, and system application. This means they have to be aware of local, state, and federal codes. For instance, the International Mechanical Code and the International Energy Conservation Code set minimum standards for safety and energy efficiency. Each area may have its own amendments, adding to the complexity. Next, engineers must also consider standards from the American Society of Heating, Refrigerating, and Air Conditioning Engineers. These standards help define what is acceptable for energy efficiency and indoor air quality. For example, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, Standard 90.1, outlines energy efficiency requirements for commercial buildings. This influences how engineers size systems and choose components. Moreover, HVAC systems do not work alone. They need to be coordinated with other systems like electrical and plumbing. This coordination is often referred to as mechanical, electrical, and plumbing coordination. Engineers must plan carefully to avoid issues like ductwork clashing with electrical conduits. If these systems do not fit well together, it can lead to expensive redesigns later on. Another factor is the balancing act engineers must perform. They need to consider energy efficiency, comfort for occupants, indoor air quality, and costs. For instance, increasing ventilation improves air quality but can also raise energy use. Engineers must find the best balance while still following regulations, which adds another layer of difficulty. Additionally, regulations often requiring that systems are designed for easy access and maintenance. This means that components like ducts and valves should be positioned so they can be serviced without major disruptions. This practical requirement influences how engineers lay out systems and select equipment. Finally, there are specialized regulations, such as the Unified Facilities Criteria, which apply to federal and military buildings. This adds even more requirements for specific projects. In practical terms, mechanical engineers must conduct thorough code reviews and work with different teams. They often use advanced design tools like building information modeling to manage all these regulations. This ensures that HVAC systems are safe, efficient, and compliant throughout their entire life cycle. Understanding these regulatory frameworks is essential for mechanical engineers. It helps them deliver reliable and compliant HVAC solutions in real-world applications. So, the next time you think about HVAC systems, remember the complex web of regulations that engineers navigate to keep us comfortable and safe.